Hi, this is Richard C. I'm recording an answer to a question submitted by a student. This is right out of Algebra 2, very straightforward. Um, we just need to find the equation of a polynomial. So let's get started. So we're going to start with, they wanted p of x. Normally we'd just write y, but okay, they want p of x instead of y. I guess that's to remind us that this is a polynomial. Now, it has a root at x equals 1. So if 1 is a root or 1 is a 0, these are synonymous, root and 0. If 1 is a root, then x plus 1 is a factor. X minus 1 is a factor. And then the other root, and it has a multiplicity of 2, so we're going to square it. And then the other root is negative 5, so that's going to be x plus 5. And it has a multiplicity of 1. Well, we could put a 1 here just to remind us, but it's not necessary. And then we just need a little constant in front, which we traditionally call a. So that's our equation. Now, if we want to evaluate a, we have to do some work here. The y-intercept is negative 1. So you can see that we can solve this. Negative 1 is equal to a times 0 minus 1 squared. You see, because y-intercept, just think about the y-intercept. Anything along this y-axis, x is 0. So any point along here, x is going to be 0. So I can just plug a 0 in here. And so negative 1 is equal to a times 1 times 5. So that's going to be 5a. So a is going to be equal to negative 1/5. And so now we can write our answer. P of x is equal to negative 1/5 times x minus 1 squared times x plus 5. And that's it. It's nice that they gave us the y-intercept. You have to have the coordinate of at least one point that this curve goes through. And well, I guess they're not asking for a sketch, but while we're here, since this is so quick, we'll put in a sketch. So here's positive 1. Here's negative 5. And this is a odd degree, third degree polynomial with a negative. So it starts, so the end behavior looks like this. And we know that it goes through here. And we know it bounces here because the multiplicity is 2. And then it comes right down there. I didn't draw that very well. Do it again. It crosses here because the multiplicity is 1. It bounces here. And then it goes down like that. So you can, if you know your end behavior and your multiplicity rules, you can sketch the graph very quickly. Okay, so that's it for this one. You'll get good at these. You just need to do a bunch more of them. I'll see you again next time. Bye-bye.